Stop sharing, yeah? Okay.
Stop sharing.
Yeah.
Can I start, sir?
Yes, yeah, please.
Yes.
Every day is a good day. There is something to learn. Today is great opportunity for that. Very pleasure morning to one and all present here, and especially the participants. It is our great pleasure and honor to welcome you all for this Knowledge 4.0 webinar series, which is one of the unique initiative of Chennai Institute of Technology under the guidance of our Honorable Chairman, Sri P. Sriram, a successful first generation entrepreneur, a well-known industrialist and managing director of MK Group of Companies. Under Knowledge 4.0 webinar series, we have been conducting webinar series such as Technical Webinar Series, Research Webinar Series, Career Guidance Webinar Series, and Innovation Webinar Series. Chennai Institute of Technology was established in the year of 2010 by our Honorable Chairman, Mr. P. Sriram. Now, our institute being ranked within top 10 engineering colleges among Tamil Nadu. Today, we have our special guest, Dr.S.V.SrinivasanPrincipal, to share some knowledge about research areas and opportunities in environmental science and engineering. Now, I would like to welcome our beloved principal, Mr. Parthiban sir, to deliver his welcome address. Welcome you, sir.
I welcome Dr.S.V.Srinivasan to this inaugural, that is a webinar on the research, that is avenues for science and engineering. So Dr. Srinivasan is one of the well-known expert in the environmental area. So I'm happy to introduce Dr. S.V. Srinivasan. Now he is currently working as a principal scientist at Central Leather Research Institute, that is a CSIR laboratory. He did his bachelor degree in civil engineering and completed in the year 1994. He did master's degree in environmental engineering and completed in 1996. Dr. Srinivasan obtained his PhD in the Department of Chemical Engineering in Indian Institute of Technology, Madras, Chennai in 2009. Regarding his experience, he started his career in 2000 as an assistant environmental engineer at Central Pollution Control Board, New Delhi, and he served till 2002. Then he started working in Chennai, that is Central Leather Institute, Chennai, that started his career as a scientist B. From 2002 to 2007, he served as scientist B. 2007 to 2011 is a scientist C, and senior scientist from 2011 to 14, and currently is a principal scientist since 2014. His research area includes is a approved research supervisor for Anna University, University of Madras, and Academic Council Scientific and Industrial Research, New Delhi. He handles the class for environmental courses, BTech and MTech in Anna University, guided many projects, both UG and PG, delivered guest lectures in training program and short-term organized by Tamil Nadu Water Supply and Drainage Board, engineering colleges, leather associations. His research interest includes treatment of municipal and industrial solid waste by biological and thermal method for recovery of energy. The next one is a biological and advanced oxidization treatment process for the industrial and reclaimant wastewater. Life cycle assessment and sustainability assessment of waste treatment technology. For his credit, he has published more than 24 journals in the international level and 13 journals in the national level, and also many conferences, includes 36 international conferences and 8 national conferences. In total, around 85 publication for his credit. He has received many awards. A specific award is said to be that DST DAD award under the exchange of scientists under engineering scientists to visit Germany. A life cycle assessment award from UNEP for project proposal on improved leather processing and latest waste treatment technology for sustainable of leather industry using LCA. He has achieved third rank in the university during his bachelor degree. Awarded travel grant UNESCO to participate World Engineering Convention at Shanghai for paper presentation. He has also filed patent in this regard. So a very good expertise in the field of environmental engineering. I have also visited his laboratory and CLRI. There are a lot of facilities for carrying out the research in the environmental areas. So I once again welcome Dr.S.V. Srinivasan for this program. So now I hand over to the 11A to continue. Thank you very much.
Very good morning to one and all. And I thank Chennai Institute of Technology and Professor for inviting and introducing myself very nicely. And I would like to take up this opportunity to give the researchers and the people in the working in the field of civil and environmental engineering what are the opportunities and what are the areas where we can work, and what is the current trend that is requirement of the globe, based on which we have to select areas. So what I'll give you is I'll share my presentation, sir.
Yes.
Can I share now?
Yes, yes, sir. Please, sir.
So is it visible, sir? Is it visible, sir?
Sir, it will take time. Just one.
Okay.
You shared, sir?
Just a minute. Share.
Yes, yes, sir.
It's visible. Okay. Yeah. Is it comfortable, sir?
Yes,
Is it
sir.
visible? And okay, yeah. So I would like to give a few areas of research where actually the environmental science and engineering people can work on, and also the opportunities available for the engineers, especially working in the field of science and engineering. Actually, if you see the environmental science engineering, it's just interdisciplinary. It requires a lot of expertise in different fields. We have basically the environmental science started with environmental engineering started with the public health engineering services for the public, and based on that, the public health engineering has been converted into environmental engineering, and now actually it get diversified, and we require previously only the civil engineer used to be part of environmental engineering. Now actually based on the technology development and requirements of the branch, we take the help of microbiologists, biologists, biotechnologists, even chemical engineers, mechanical engineers, even other branches of science also is taking involved in this environmental science and engineering branch. So let me go into the details. First, actually, if you see the environmental science and engineering, we can convert or we can categorize it to major three categories. One is the air. Actually, one of the major requirement for the survival of the human. So without air, we cannot survive. So air is the one which actually provide the oxygen to the human health, and when it has contaminated, it has a lot of impacts on the health as well as on the other materials. So air is one of the main component. Then we have the water. So water is also essential for the human as well as for other commercial activities. Without water, we cannot survive. So that's what I think we also heard of. The third world war will be because of water only, because of that demand and requirements of water and shortages. And the third other major issue that is coming up is the solid waste. Actually, previously solid was not a major issue, but nowadays solid waste is becoming very aggressive, and it also have a lot of impact on the environment. So these are the three major categories. In addition, you can go on detailing it, but we can categorize the environmental engineering in science and engineering into three major categories. So within these three categories, what we have is the air pollution is a major subject that comes under the environmental science and engineering. So the air pollution, as I mentioned, it is very essential for the human, and it get contaminated because of many major three reasons. We can say the industrial air pollution. So the industrial activities, especially the air polluting industries, like we have the thermal power plants. The thermal power plant is required for supplying the energy because we need to supply the energy for the public. Public requires when there is a change in the quality of life, the energy demands are increasing, and also population is also increasing. To need to supply the energy requirements of the population, we have to increase our energy demand. So when you go for increasing energy demand, automatically the air pollution or what you call as the air pollution industries also has increased. So thermal power plants and the cement industries. Cement industry is one of the major air polluting industry. So, and we also have a metallurgical industries, especially steel, aluminum, all these things comes under the metallurgical processes, which emits a lot of air emissions. So industrial air pollution is one of the major area where actually we can do a lot of research in this field, and we can also contribute for reducing the environmental impact. The next to industrial emissions, the other major issue that is coming up is the urban air pollution, especially the urbanization is taking place at a very faster rate, and urbanization, I think, as of now, actually two-thirds of our population is in the urban centers, and it is likely to further increase. So when the urban population increases, automatically the energy demand increases, and also the vehicular traffic and other emission takes place in the cities. So because of the urban traffic and vehicular pollution, the air pollution is a major issue in the urban cities, and you might heard of all that major pollution coming from Delhi, Bombay, and other places. And a lot of efforts also being taken in the urban areas, especially for controlling the urban pollution in terms of mass transport systems, or even the vehicular systems. We have different fuels. Instead of using a conventional diesel or petrol, we can go for CNG and other modes of pollution fuels, which are cleaner fuels, which will reduce the emission to the environment, thereby reducing the urban air pollution. And we also work on we can also work on the different areas of traffic management, how to control the traffic so that the air pollution can be reduced. So we can think of having flyovers or mass transport systems and dedicated bus lanes. So many things are there which will reduce the air pollution. So there actually, as I mentioned earlier, it is an interdisciplinary area where other branches of engineering, like traffic engineering, also plays a role in vehicular pollution control. Even what you call climate or atmospheric sciences people also can contribute for the air pollution. Similarly, the mechanical people, mechanical engineers and IC engine designers and fuel experts also can contribute for vehicle reducing the air emissions in the urban areas. So these are the areas where actually urban air pollution can be controlled, and the people can work on these areas. And another major, that is the climate changes and also the global problems related to climate change and ocean depletion. And the greenhouse gas emission is one of the culprit for this climate change, and we have a lot of greenhouse gas emissions, CO2, methane, and other things. So, what are the potential areas? I'll be showing at the later stage what are the different emissions responsible for the global warming, and out of that, a major amount of is coming from the different sectors, not only from all sectors contribute. You may not be thinking even agriculture is good for everything, but even agriculture also has impact on the climate change, and even industries, transportation, waste disposal, everything relates to greenhouse gas emissions. So how to control these emissions? So individually, even the greenhouse gas emissions can also be controlled by, for example, now we are organizing this seminar. This seminar is a webinar. So this everybody sits in their own house or offices, and we are having a meeting. If this happens, if the same meeting happens in Chennai Institute of Technology as a normal seminar, so what happened actually? I'll be traveling from my office at Chennai to Chennai Institute of Technology, and all your participants have to travel, and all your vehicular emissions will be there, and also they have to make arrangements for the AC hall. So there is a lot of energy requirement, and after that we'll also have a lot of papers, other things, mode of preparation of materials, things like that, and all leads to directly or indirectly emission of greenhouse gases. So this is responsible. This actually, this webinar has avoided all those things. So webinar, you can say, is an innovative method. The person who has developed this webinar is also one way has reduced the greenhouse gas emission to the environment. So that is how actually everyone can contribute. Though I say it's environmental engineering, even we can think of the what do you call as a printer. We have HP printer. Previously, we used to have one side paper printer. Now we have two sides. So even if it takes two sides, automatically what happens? Automatically one paper is saved for every 2 pages. So the one paper means it is 50%. That means roughly 50% is reduced. 50% of paper demand is reduced. 50% of paper demand is reduced means what? Automatically so much amount of deforestation or tree cutting is also widened. So we can every aspect, every activity also have directly or indirectly impact the climate change. So we have to all in the even household homemaker also can contribute. For example, if you see the energy consumption in domestic activities, we can also save. A lot of things are there where you have a lot of energy saving machines, energy saving equipments, energy saving lighting systems. All these can contribute to reduction of greenhouse gas emission. So everybody can contribute for this climate change. So that is how there are a lot of areas in which we can work on this climate change, especially in the avoiding the greenhouse emissions, or even if it is generated, mitigating that. So all different options can be considered. And ozone depletion substances, CFC, chlorofluorocarbon. Actually, now we have now a lot of alternatives, refrigeration systems free from this CFCs or come up, and this also is a new area. Actually, people can work on it. And these are the major areas where actually the research can go in and also contribute for the development of the world. And next is the water pollution. So as I mentioned here, the water is one of the another essential next to add for the survival of the human and also other commercial activities. So we can consider the water into two categories. One is water, that is the drinking water or water for commercial activities. Another one is a wastewater, that is generated from the domestic or industrial activity, that is the used water. So the drinking water quality, as I mentioned, in some places actually, especially the West Bengal, other places, we have some issues related to arsenic, fluoride, TDS, salinity. Especially in Chennai, most of the places we have we use groundwater. That time groundwater has a lot of high TDS. So these are the issues that is coming up in major places, and making the water portable for domestic and other users is one of the major constraint, and people can work on this area of research also, so that how it is affordable, even how it is decentralized, and household based equipments like that we can work on it, so which can provide a solution for the public. And the next one is the surface water, especially the river waters, groundwater, and marine ocean. Everything is getting contaminated, and we also can do a lot of studies on the, because when you want to do any remediation measure, we should know the change in the quality. If there is any change in the quality of the water before and now after the industrialization, we have to monitor the quality of water at different stages. So continuous monitoring of surface water, groundwater, and marine water is also need to be done, which will help the policymakers as well as engineers to find out the remedial measures to control the changes in the quality. So that quality water quality monitoring also can be done, continuous online, everything can be done, which will provide find out the provide opportunities for working on the different remedial measures for controlling this or reducing the water quality impacts. Next to that is when you come to the wastewater, we have different methods of treatment. Wastewater is wastewater, that is nothing but the used water. The whatever we use, after that what comes out which cannot be used for further use, further application, we discarded the wastewater, that is the used water. So this wastewater is mostly generated from domestic activities as well as from the industrial activities. So if it is generated from domestic activity, it's called as domestic sewage, or what you call as domestic wastewater. Or if it comes from industrial wastewater, we call it as industrial effluents or industrial wastewater. This actually has the different pollutants. You can see the pollutant present in the wastewater can be categorized in solids, that is suspended solids, and dissolved organics and dissolved inorganics. So we have to provide solution for treatment for all this separately. So we have the physical methods and chemical methods. Physical methods like settling, filtration, chemical methods like coagulation, oxidation, and biological methods using anaerobic and aerobic bacteria can also contribute for this. This is not anaerobic and aerobic bacteria can contribute for the reduction of organic load in the wastewater. So there are different options and different technologies are available, and still a lot of innovative methods can be applied to reduce the mitigate this suspended solids and dissolved organics and inorganics. Apart from this physical and chemical biological methods, we also have advanced treatment methods. Advanced treatment methods like, especially after the removal of conventional pollutants, suspended solids, BOD, COD, we have some pollutants like nutrients. Nutrients means nitrogen and phosphorus. So the conventional treatment, the nutrient will not be removed. The nutrient will be coming out in the treated effluent. So we have to provide a treatment for the nutrient, because now the nutrient are going to the environment, surface water especially, and leads to algal blooms and other environmental hazards. To control that nutrients, we have to have a advanced treatment in addition to the conventional primary and secondary treatment. So there are advanced treatment for removal of nutrients, and also some of the industrial effluents. We also have recalcitrant compound. That means the compound which cannot be degraded with the conventional system. It will not get removed in the physical treatment, and it will also get not removed in the biological treatment methods. So we have chemicals, dyes, and other chemicals that are used in the processing also lead to the recalcitrant compound, which is not easily biodegradable. So we have to find out advanced oxidation processes or biological advanced oxidation with the biologicals or different combinations has to be tried, especially the ozonation, things like that we have to try, or hydrogen peroxide, strong oxidizing agents. So this type of recalcitrant removal also can be done with this advanced treatment methods. And in addition to that, now even our domestic wastewater, we have, initially we think the domestic wastewater means it's only suspended solid, BOD and COD. Now with this lot of health issues in the public, a lot of pharmaceutical chemicals are also found in the industrial wastewater. That's called critical pollutants. That critical contaminants are also coming up, and a lot of research is also going on that area, how to remove the critical pollutants, which are in very low concentration, but will have a lot of impacts on the health, especially at low concentration, even could be have a lot of impact. And the next one is, actually I mentioned, the wastewater is the used water. That means the water that is used. So this actually used water has some contaminants. If you remove the contaminants, now we get a water back. That is called water recycling. So the wastewater recycling is also a new concept, and this is a new concept in the sense for some of the new people it will be a new concept, but it is still working in Chennai itself for last 16 years. Recycling concepts are working in other parts of the world also, and this is very much required for the current scenario, because water shortage is there everywhere, and there is a lot of gap in the water demand and supply, especially in Chennai itself. We are not getting the adequate water supply. The water supply requirement is 135 liters per person per day, but we are not getting 135 liters because that much water is not available for Chennai. So we are getting shortage of water. So how to manage this water? So what we do is, we do a lot of treatment of this used water after the conventional biological treatment, and we can go for different methods like membrane-based technologies, membrane bioreactors. Actually, when you have a membrane bioreactor, the fluid that comes after will be free from all the bacteria, suspended solids, and pathogens. Even that water can be used for other applications. It may not be directly for potable. It can be used for other applications, for other low-end applications. If you want to go for potable, then we can go for ultrafiltration followed by reverse osmosis, so that it will ensure that everything is removed. And this water recycling is already existing in some of the industrial establishment in Chennai, CPCL, Madras Fertilizers, for they are buying the water from the domestic wastewater from the Chennai Metro water, and they're treating the water and reusing for the commercial applications within the process applications in the Chennai for last 15 years. Similarly, this Singapore, they also have introduced this concept of MBR followed by RO system for recovering the water from wastewater, and the treated water is also actually portable. It's called the new water that is also available, and it is not directly reused. Actually, it is recharged to the ground, and directly it goes to the water requirements of the city. Sorry. So that is how actually this water recycling is also a new area where actually a lot of work can be done, where actually there are different membranes that is coming up, and we have there are some issues like energy demand for recycling water. So now new type of membranes are coming up, and a new type of energy recovery system, forward osmosis, and also the other new concepts are coming up, which will also increase your water recovery rate and also reduce the energy cost of treatment. So that is also another issue, another concept that is coming up, area which need to be concentrated on. So now we have other one is municipal solid waste. When you come to the solid waste, as I mentioned here, this third another major category is the solid waste. In the solid waste, we have municipal solid waste, that is a waste that is generated for the domestic, for the urban areas and rural areas, domestic activities. Another is the industrial waste, that is from the industrial processing. That is in the industrial waste, we can have two categories: the hazardous waste, that is covered in the hazardous waste rules of MOF, and the non-hazardous waste can be also be the other group of waste which can be taken up for other applications. So another group of waste is a biomedical waste generated from the public hospitals and other private hospitals where medical facilities are there. So these three are major categories of this solid waste. Municipal solid waste, we'll go in detail about the municipal solid waste. Actually, I'll give you a case study, whatever the research areas. I'll give you a couple of case studies from municipal solid waste, how we have handled, how we have tried to address this issue of municipal solid waste using the research approach. And industrial waste, as I mentioned, hazardous waste, we have two type of treatment options for the hazardous waste. One is incineration, another is the landfill. So incineration, well, if you have a calorific value, it can be incinerated, and if it is not that much having calorific value, it goes for landfill. Now, actually, if we can recover or do some work on this hazardous waste and find some alternatives or recycle, whatever possible methods we can do, it's very much required, because as of now, the landfills is it's a final option, and it's not solving the problem. It is only a temporary solution, and we are postponing the problem. The landfill is not a permanent solution, it's a temporary solution, and this pollutant is going to exist in the earth till we may not be there, but our generation will face the same problem. That is, we have to do a lot of work on the hazardous waste, so that we can. One is the hazardous waste generation can be avoided, where actually even the chemical engineers and process chemists can also work in avoiding the generation itself. If they can avoid, that is also very much appreciated. Once if it is generated, then we have to work on how to recycle or recover the valuables from that, so that the hazardous nature can be reduced. That is how we have to work on the hazardous waste. That is how a lot of areas we can do, a lot of things that can be done on this hazardous waste. If you go to the hazardous waste rules, they will be giving you different categories of hazardous waste generated from different industries. So if anybody interested, they can see the different hazardous waste generated and find if they have some innovative knowledge, they can work on it and try to address the problem of hazardous waste. And some non-hazardous waste like fly ash and other residues comes from the industrial waste, also solid waste, but it is not coming under the hazardous category. That is non-hazardous waste that can be utilized for fly ash based bricks, fly ash based material, construction materials are coming up. All other things also, a lot of things are coming up, and which can work on this. And geopolymer concrete, this lot of things can be done with this fly ash. Like that, we can also work on that. Then, as I mentioned, the biomedical waste. As of now, the biomedical waste is segregated, and there is a separate rules for that, handling the biomedical waste. And there is also a lot of requirement of doing research, because especially as of now, the Most of the things go for the landfill. So the biomedical waste is, as I mentioned, this also can be in different categories. In the generation itself, we can avoid it, or the management options and recycle to the extent possible, recycling recovery methods, and it should ensure that safety norms also, that it cannot be recycled just like that, and recycling norms also have to be met. All the safety precaution has to be taken care of. All these things also, yeah, new areas where actually a lot of work needs to be done in that. In addition to these three major air, water, and solid waste, other areas of research that can be carried out in the field of environmental science and engineering are biotechnology. Because as I mentioned here, here the biological route we are using for removal of organics, BOD and COD, and here also we have different methods by which we can remove the nutrients, biological nutrients. And this recalcitrant compounds are the phenolic compounds, dyes, or chemicals, which is not easily degraded by the conventional bacterial system which we use. So we have to find some biotechnological applications for waste remediations. This biotechnological application can be in the form of microbes, or it can be in the form of new microorganisms, identify special species which can degrade these hazardous chemicals or leach out these chemicals. Like that, we can work on the biotechnological aspects for waste remediations. Apart from that, we also have the environmental impact studies. Especially, we do a lot of studies on the environmental. I mentioned about the water quality, and we can also monitor the air quality and what will be the impact in the different ecosystems. That also can be done with the help of a biologist, even geotechnical experts. All those in groundwater contamination, all this can be done at a different levels to identify the impacts, environmental impacts, because of domestic or any industrial activities. And I am actually also interested in want to cover this aspect, environmental economics, because actually as of now what we think is, as of now we are thinking of only the current treatment option and the economics, but actually the future we also have to consider. If we don't do it systematically, if we don't control the air emissions and other, if we don't maintain the environment safely, in future we may have to face a lot of problems. So the environmental economics will estimate the, because of the environmental impact, what will be the loss of because of the health, and because of the productivity from the agriculture and other aspects. So all this comes under environmental economics and environmental law, because when we want to monitor and regulate the industries and domestic activities, we have to have a environmental law which will also preventive as well as a uh, end of pipe treatment approach. Both the same we have to work on law and health impacts, because based on the lot of health studies only, we go for a different type of treatment methods. For example, if you see the health impacts, so we can see the lot of changes that has happened, the vehicular emissions because of the lead. You might have heard previously we used to have a leaded petrol. Now the lead was coming in the air emissions, and it was entering the human system, and it was found everywhere in the blood and urine, everything. Lead was there. So there only they changed to vehicular pollution. That is, what is the source of lead? They found that is a leaded petrol. The petrol is used in the vehicle, diesel or petrol. So that was completely removed. Now we have an unleaded petrol. Like that, we have a, so the health impact studies will be a indication what type of preventive measures need to be taken to control the such pollutions. Next one is soil pollution. Actually, that is mostly because of the groundwater, and also disposal of the waste on the soil has lead to soil pollution. So that also is another area which requires a lot of work. These are the major areas. In addition to that, we also have to do a lot of work on the policy initiatives, policy people, what type of preventive measures, policy research is required to have a control on these emissions, regulations, etc. And also the education, especially the teaching in the research areas. We do a lot of research and awareness, all comes under the education. Then we also have the sustainability, that is called whatever is the production, whatever the growth, it cannot be at the cost of environment and social. So everybody should benefit out of it. There is any commercial activity that should not have effect the environment, and it's also affect the public or the social activity. So everything should be a sustainable. So we have now latest development like the life cycle assessment concepts are coming up. where actually we can do a study from cradle to grave, where actually we'll take into account all the components. For example, I'll take an example of even you can take any pump. You buy a normal commercial pump. We have two different pumps. One is a 5,000 rupees, which is a normal pump. Another one is a energy efficient pump, that is 10,000 rupees. For example, if you go to the market, we'll buy only um, uh, the pump with the 5,000 because it is giving the same specifications. Like more or less, you'll be able to get the same amount of water. So this is same head is there. So I'll go for the why I should spend 10,000. I'll go for a 5,000 rupee pump. But actually, when you buy and operate the pump, actually during that operation, you'll find that when you use it, the electrical consumption for that 5,000 pump may be 500 rupees per month. If you use the same the energy efficient pump, it may do the same purpose with 300 rupees or 250 rupees. So there will be saving during the operation. During the capital investment, you have to spend little more, but during the operation, energy demand or energy requirement for operating it for the same performance will be very less, 50%. So if that is the case, or even if it spent to the 10,000 rupees, whatever the investment you are making within the 2 years, you'll be able to take the capital investment. So the return of investment will be only you'll be able to save after 2 years, whatever the saving, that is 250 rupees coming as a saving for you. So you'll not be able to know which one is energy efficient. That's why actually now we have come up with the Bureau of Energy Efficiency, which also works on this concept. We come out with a star rating. You might have seen that different stars, 5-star AC, 3-star ACs, refrigerators also 3-star, 5-star, where actually a lot of energy is there, and indirectly it is related to the emission of greenhouse gas emissions. A lot of emissions. So all these things can be done with the life cycle. So here I'm just mentioning about the energy demand. Similarly, we can also consider the other aspects. For example, disposal, or when you want to dispose some of the product after use, that may be very difficult, and it will have more impact. So that all will be taken into account during the operation, during the disposal. Everything will be taken into account while considering the life cycle assessment. So these are the areas, major areas, in which the environmental science and engineering can be done. And I'll just take a couple of examples where actually I'll just give a few studies what we have done in CLRI with respect to municipal solid waste. So you can say that energy problem. Actually, if you see the municipal solid waste, it is a major issue, and this generation of mixed waste, what we get is also a mixed waste. We are not segregating at source, and if you see that the mixed waste will not be able to find a solution. So what happens when you have the municipal waste? If it is organic, this organic can be composted, or it can be sent to the anodization process. We can take the energy out of it. If it is a plastic waste, we can send it to the plastic recycler. He can recycle and reuse it. If it is a paper waste, it can go to the paper recycling facility. If you have any other plastic or any other product, electronic, and it goes for electronic recycling. But if it is all is mixed, then we don't have any solution for the mixed waste. So that is the major problem we are facing with the municipal solid waste. And the conventional methods, I'll explain to the details. And another major issue that we are facing is the energy demand. So the energy demand is always there is actually, you might have seen a lot of places we are still a lot of energy shortage is there, and every year we are able to find there is always a gap between the demand and supply that needs to be managed. So for the conventional method of managing the gap is using conventional source of fuels, and it's also limited, and it also have a lot of impact on the climate change. But alternative is to go for a renewable source of energy, especially the solar, wind, tidal. To major extent, our India is concentrating in solar, and a lot of work is also done. Wind energy also is coming up, and tidal and biogas is also another areas which can get alternative or renewable source of fuel, which will be have less impact on the environment and also benefit for the society. So we have, as I mentioned, we have the municipal solid waste. That generation is about roughly 0.5 kg per capita per day, and this is likely to be increased because because of the change in the lifestyle of the people. The municipal solid waste quantity is likely to be increased. It is likely to be double by 2025. And the conventional treatment methods, as of now, is they go for scientific landfilling or things like that, or go for, if it is a compostable, they go for a composting process. But as it still is a mixed waste, it is very, very difficult to go for a composting. If you have a segregated waste, very well it is possible you can go for composting or anaerobic digestion. Still, we are getting a mixed waste from the most of the places in India. That is a contributing factor. So the greenhouse gas emissions. We have a lot of greenhouse. As I mentioned, the climate change. We can see the sector that is contributing for the climate change. This climate change, I mentioned a couple of gases responsible for climate change. The CO2 that contributes 75%, and methane is about another 17.3%. Nitrous oxide and other gases. These are the major gases that is responsible for greenhouse gas emissions. And these gases, you can see that waste, the municipal waste and the industrial waste, is also contributing for about 3.2% in the form of mostly the methane. Because when you dispose this waste on the landfill or on the open dump, this emits CO2 and methane because of anaerobic activity. This methane is roughly having more global warming potential than CO2 to that extent of about 21 to 21.5 times more global warming potential. And we can also see the other sectors, the different sectors contributing, transportation sectors, electricity, buildings, manufacturing sector, construction, fugitive emissions, industrial processes. So as I mentioned, when you people want to work on their research areas of mitigating greenhouse gas emissions, you can find out any researcher or any discipline can participate in this. If he's a traffic engineer, he can also concentrate on the transport system, how we can reduce the greenhouse gas emission to the environment. If it is electrical or electronics people, they can also work on the electrical and heating applications, mechanical, electrical vehicles, and the building material. Now that green building concepts are coming up, where actually we can use less material, less CO2 emitting materials, green materials, green buildings concepts are coming up, where actually the lot of CO2 emission can be reduced. And industrial processes. So all the industrial processes we can do. As I mentioned, agriculture is also contributing for that. Agriculture experts or also agricultural scientists who also can contribute for mitigating this. Land use and forestry development also contribute to that. So everybody can contribute in this area of greenhouse gas emissions. And as I mentioned, the municipal waste is also contributing to the extent of 3.2. So what we are trying to address is this 3.2% contributed by the waste. So as I mentioned here, the urban municipal waste is a mixed waste, and especially we have some amount of organics, about 50 to 60% organic waste is there. But if you go for a residential, we will not be able to segregate. This is actually be segregated source and has to be collected. So that is a major problem we are facing. And what we try to address is who are the potential bulk generators of waste, especially the bio waste, organic waste, which is easily biodegradable. This biodegradable waste can be from the bulk generators. So what we try to do is identify the bulk generators of the organic waste, which is segregated, which is not mixed with other plastic or other paper, etc. And this bulk generator of waste we want to utilize for generation of energy. That is how we develop the concept of recovery of energy and value-added products from the bulk biogas generators in the urban area. I'll just go into the details of bulk generators. As I mentioned, the energy crisis there, waste problem and greenhouse emissions is the other hand. We have these two major issues, and how we can solve this issue. We can take energy from the waste, which will solve the problem of waste, as well as also reduce the greenhouse gas emissions by reducing the amount of waste going to the landfills. And this can be achieved by two methods. One is a thermal method, and it's a biological or anaerobic digestion process. Thermal methods actually suitable for dry fractions of organic waste, which is not having much moisture content. Then it can go for a dry fractions, thermal gasification or pyrolysis, we can go for it. If it is having a lot of moisture content, then we cannot go for thermal. So it's more suitable for anaerobic digestion processes. So wet fractions of organic fractions can be very well can be taken into the anaerobic route, by which we can generate energy of that. So anaerobic process, everybody must be aware of it. It's a process which works in the absence of oxygen. The organic contaminant is converted into methane and CO2 help about microorganisms, that is anaerobic bacteria. So these anaerobic bacteria, these are the different states. Actually, we say it's organic pollutants going to methane, but there are a lot of intermediate steps. That is all shown here. It's different steps. You can see the biomass. First, it will get hydrolyzed, get converted to simple compounds. Then it will be acidified, it converted to different acids, and after that it will get converted to estrogen, it get converted to acetates. Then goes to the biogas. So methane and CO2. Similarly, there is another route by which we convert it to directly acetate, and acetate goes to biogas. So this route, actually, we have a biomass that's organic waste or municipal organic fraction of municipal waste getting converted to biogas. So we have a lot of steps involved in that. These steps are controlled by the different factors when you operate in the reactor system. So the amount of that is we measure in terms of parameters called organic loading rate, retention time, temperature, pH. All these factors have influence on the overall process conversion and generation of biogas production. So these organic loading rate parameters will be monitored in the lab scale studies. So when you go for anaerobic digestion, that is the biological method, what are the advantages? So when you go for the anaerobic digestion process, we have advantages like energy and economic benefits, like energy generation. So we get the biogas, which has a lot of calorific value, which can be used for heating or converting electricity. Energy is possible out of it. And it is a potential to treat, as I mentioned already, it's a wet fraction can be treated in this. And actually the economic benefits from energy perspective, in the future, there is energy is going to be a very commercial commodity, and the energy prices are going to be increased in future. So that will the additional benefits of this method, anaerobic biological processing. If you see the apart from the economics, what are the environmental benefits we get out of this anaerobic digestion process? It's an environmentally sound process. That means we don't have any byproduct which is more contaminant or doesn't have generate any secondary pollutants, things like that. So we get a recycle benefit that is compost, or we call it as the digestate. After digestion, what we get is the digested material that can be used as a manure or compost for the agricultural application. So that we be able to recycle the nutrients that are available in the bio waste. And the land requirements, environmental benefits in the sense land requirements are less when compared to the aerobic composting process. We go for a conventional composting process, is require a lot of space. So that will be require a lot of space. That is one of the major constraint in urban areas, getting so much space for waste treatment. So comparatively, it requires less space compared to the composting processes. Apart from that, what are the other benefits we get in the waste treatment benefit? Volume reduction. So there is a substantial volume reduction for further disposal or recycling, and the potential for co-digestion other waste. Actually, if you have organic waste, not necessarily that it should be designed for only a particular waste. If you have 2-3 type of waste, we can also mix it and utilize for the biogas production. We do not have a separate digester for different waste. We can have a centralized facility where we can use the waste from the bulk waste from the vegetable market or slaughterhouse, things like that. Or we can, even if there is industry which is producing non-hazardous biodegradable waste, it also can be utilized. So co-disposal, that means co-treatment. We can have a single treatment. This can help. So I'll just go through your activity, what we have done with the different bulk waste generators from the city. So we have taken Chennai as a case study, and we have taken different bulk generators. One is a vegetable market, that climate waste, like you can see the different, you can see the cauliflower, fruits, onion, a lot of waste, flower waste. The climate waste is a fruit and market, it's a vegetable market, complex market for, wholesale market for vegetables, fruits, and flowers also. So we have about 150 to 200 tons of bio-waste, segregated waste is generated from that. Already they have put up a biogas plant for the vegetable market waste for about 30 tons. It is already operational, pilot plant. And we also have other waste. As I mentioned, other bulk generators is the chicken shops. Like you might have seen a lot of chicken shops in Chennai city, where actually the chicken waste is about 30%. For every animal cut, we get about 30% as the waste. So that is another major waste that is coming, bulk generated, that is not mixed with anything else. And the fish market waste, the chicken waste, and also the slaughterhouse waste. And the slaughterhouse waste, where actually we have small animals and large animals. And when most of the So the small animals, all the components are utilized except the undigested material from the stomach, the cow dung, like undigested agricultural waste. That is another one. And some places, large animals, we also get blood. Blood is also not taken utilized. It is also is wasted along with the cow dung. So what we have done is to address this issue of the different components of bulk generators. We have taken up a research study on this municipal solid waste funded by Indo-German Science and Technology Center, where actually we have 4 partners. CLRI is an academic partner for Indian side, and German side we have Leibniz University German side. These are the 2 academic partners, and we also have industrial partners from German side and Indian side. Indian side is Ramk's industrial partner, and Biomecon is a company which is Biomecon and Lehman are the companies from German side. So we have taken up 2 projects. I'll explain this how we have gone about this addressing this municipal solid waste. The first project actually what we try to do is here actually what we have done to is resource and energy reliability by co-digestion of vegetable market waste and slaughterhouse waste. As I mentioned that these are the major 2 wastes, that is vegetable market waste and slaughter waste are the major waste that is generated, and it has a lot of potential for generation energy, and it is completely organic waste with the 90%, 85 to 90% moisture, and also fully organic. Alright, solid content is about 90%, so it is very much suitable for going for anaerobic digestion processes. So what we have done is actually, as I mentioned, the waste treatment benefits. We need not go for a dedicated anaerobic system, so we can go for a mixed waste. So co-disposal concept we have gone for it, and the vegetable market and slaughterhouse. And when we go into the details, what happens? The vegetable market waste actually, as we think, it is a vegetable market waste. As I said, the bulk generator of organic waste, the vegetable market waste. In the vegetable market waste, we have the fruit market waste, flower market waste, banana pedangle. Actually, the banana pedangle means the central portion of the banana stem, and where actually we get about 20 to 30, 35 tons of banana pedangle as a part of the vegetable market waste. Slaughterhouse waste, as I mentioned, chicken waste, fish market waste, canteen food waste. Especially the food waste is also coming from the different institutions, universities in the city, urban area, small canteens, hotels. All this has a lot of food and kitchen waste that also can be utilized. And the residual organic fractions, actually the residential waste, it's a mixed. As of now, what we are getting is a residential mixed waste. If we can segregate that organic fractions also, then it will be a potential bulk generator which can be also utilized in the biological treatment processes. So how we have gone about is we have tried to take the different waste and try to estimate the biomethane potential of this waste, and we have prepared an equipment that is automatically measures the biomethane potential, and we monitor the amount of biogas that can produce from that waste for a particular within the particular period. So that is measured, and based on that, and we found that a lot of other potential is available. And what we found is as I mentioned, the vegetable market waste. What we have is a banana pedangle. Banana pedangle is a fibrous waste which has a lot of organic content, but it is not easily degradable, and also it cannot be easily shredded. So the existing facilities for banana pedangle shredding and all is not available. So what we have done is actually we have taken the help of our German partners, especially the industry partner, Lehman, who is designed extruder. It's called by-extrusion process, where actually the waste will pass through that, and it will be having 2 screws. The waste will pass through the screws and will be shredded, and it is also size also will be reduced, and also the waste will be subjected to some temperature and pressure because of the extrusion process, and that changes the composition of waste and also increase the biodegradability of waste. So that enhances the biogas production also. So we have done the lab scale studies, and also now we have gone for a pilot plant, and the bio-extruder has been designed for this pilot plant, and it has been transported, and it is now installed in CLRI, and you can see the container-based bio-extruder, and the waste is also extruded and is collected in this. So this is a new concept where actually the pre-treatment using a bio-extrusion and also the co-digestion process. These are the innovative option by which we have taken up this study. And we have done the lab scale and continuous studies with the lab scale experiments also. Based on that, now we have put up a pilot plant, biogas plant. Actually, the waste will be collected from here and it will be conveyed to this. Here also we have a shredder, specially designed shredder, which even shred even the banana pedangle, things like that. And from here it will be pumped to the conveyed to the extruder. From the extruder waste will come here, and from here it is pumped to the digester. So the digester is also closed system with all temperature control and other measures. And whatever the biogas produced will be collected and it will be measured in the flow meter, biogas flow meter, and the digester, whatever the gas comes here will be collected in the biogas. Well, I think, yeah, here you can see this. The vegetable slaughterhouse is conveyed to the shredder. After shredding, it goes to the bio-extruder. From the extruder, it goes to the anaerobic digester. From the anaerobic digester, the gas, whatever is there, goes to the gas flow meter, and the digester is collected and separately dewatered, and the gas, whatever is collected here. So we have put up this biogas plant under the R&D mode. Yeah, this is we also have an online monitoring system where we can measure the pH, temperature, warp inside the reactor, and we can also measure the pressure inside the balloon. And we also made all automatic measures so that if the pressure increases, automatically the valve will open, the flare will happen. And we also have a biogas purification for H2S removal and things like that. So this is the process flow diagram of a biogas plant with extrusion, pre-treatment with the German equipment, which will ensure that even the fibrous waste, which is not easily shredded, is also shredded and also is subjected to some temperature pressure extrusion process, by which we will be able to increase the biogas production. We also have a mixing arrangement. All these things are here. So this is the first set of experiment where actually when we want to ensure that all the vegetables, the fibrous waste, banana pedangle, and the banana leaf, even the leaf also has a lot of fibers. So all these things shredded and it is fed to the digester. And what we found is from our basic biomethane potential analysis experiments, we found that banana pedangle, which has a lot of fibers, and the vegetable market waste has a lot of fibrous materials, which is not that much suitable for biological anaerobic digestion processes. So what we thought is, but only if you want to take it to thermal route, the problem is we have a lot of moisture content in it. So that will not help us, allow us to go for thermal route also. So then we found that what are the alternative methods, and we worked on it and we came up with a new concept, the second project, where actually the integrated energy supply and carbon sequestration urban organic waste through combined solar sludge drying and pyrolysis. So what we have done is go for a drying process, not for conventional drying process, solar drying process. Actually, if you go for conventional drying, we have to spend energy, so that is not advisable. So we went for a solar drying process, and even within the solar also we have gone for an accelerated solar drying process, and followed by the pyrolysis, so that we will be able to get energy out of it, as well as we will also get the biochar. The end product of this pyrolysis is a char, which also have a lot of potential in them. So we have taken up this second project based on the outcome of the previous project. So we found that some of the waste are not suitable under digestion process. We have collected that waste separately, especially the sewage sludge and the banana pedangle. So we had the same group of partners from German side and also Indian side, and we had another industry, Biomecon, who is specialist in manufacturing of pyrolysis equipments. So they are the partner, and we have gone for the second project, where actually here what we are trying to do is the fibrous waste, especially the market waste, the banana pedangle and fibrous waste, which can be fed into this solar drying system. And in addition, you might have seen a lot of fibrous waste like the cities like tender coconut. The tender coconuts are sold in the city at different locations. We take the tender water. After that, we throw the tender fibers. We don't, as of now, what is the solution for that? As of now, there is no solution. So it goes along with the other waste and it is disposed of. So what we thought is we can take all these fibrous waste, banana pedangle, tender coconut, and also even when it comes in the summer season, we can get the palm fruits also. That also can be taken up. All the fibrous waste can be dried along the solar drying, and also we found that sewage sludge, that after the sewage treatment plant, what we think is the sewage is completely treated, but end of the day we get a sewage sludge. As of now, there is no solution for the safe disposal of the sewage sludge also. So what we are trying to do, it has a lot of pathogens in it. So if you want to control the pathogen in the sewage sludge, we have to go for a thermal method. If you go for direct thermal, it will be again energy intensive. We have to spend energy out of it. So what we thought is actually it requires energy, and this fibrous waste has some energy. So we combine this together. So the sewage sludge is also dried along with the fibrous waste, goes to the pyrolysis, and it is completely everything will be burnt. We will get a biochar, and whatever the heat energy is there, that will be taken out, and the biochar is the end product of pyrolysis. This pyrolysis we are not going for any oil, and our German industrial partner is manufacturing this facility, gasification and also combustion. It's a single chamber pyrolysis where you will get the heat energy. Even the gas will be burnt inside, and you get a complete the heat energy out of it. So this is the advantage of this integrated approach. That is sustainable urban organic farm management system for the. This can be implemented for the smart cities and Bharat Swachh Bharat mission, where actually we can try this concept and address the fibrous waste. So I'll just give you the process flow diagram of that. We can have a look at the fibrous waste. I'll just short of time. I'll just here the fibrous waste will be pressed, because as I said, it has a lot of moisture. It is like a sugar cane. A lot of moisture will be there. We'll try to remove the water by pressing. Then after that, we'll go for shredding, and the sewage sludge will be dewatered, and it will be taken to the mixing system. From here, mixed one will go to the solar drying process. Actually, in the solar drying process, we will also have accelerated solar drying, where actually we use a polycarbonate sheet, so that the temperature inside will be always more than the outside temperature during especially the daytime. So with the temperature outside is 35 degree, inside will be around 55 to 60 degree. So that will increase your evaporation rate. We are also planning to have some natural draft, so that the evaporation can be accelerated. So the dried waste will be taken to the single chamber pyrolysis, and after that we get the heat energy from that. The heat energy will be utilized for different applications, for any applications. And this whatever the end product of this is a biochar. Biochar is having a lot of porosity, which can be used as a manure, and also can be used for soil remediation. So this will release the carbon very slowly into the soil, and it will increase the fertility value of the soil. So this is how we propose the second project. We have just initiated this project. It's 1 year old, and we have already started the solar drying process. As I mentioned in this one, we have taken up a small lab scale experiment setup, and we have already started working on this different waste, fibrous waste. We are trying to dry it in the solar evaporation system, and we are carrying out the studies. And you can see that we also have lab scale pyrolysis system, where actually we take this fibrous waste after drying and go for a pyrolysis process and get the biochar. And we are also started doing the preliminary experiments with the biochar. And this is the pilot plant, as we are mentioning, pyrolysis that is being that has been manufactured in Germany. Now the shipment is done, and most probably in a month or two we'll be able to install in our campus this pyrolysis system. And what we are saying is an integrated approach for the solid waste, especially the municipal solid waste, is the organic fraction, wherever the bulk waste is coming up, the slaughterhouse waste, food waste, market waste, and dewater sludge. So all this food biodegradable waste can be mixed together, goes for anaerobic digestion processes. With this first project, with the extruder from Germany, and a conventional biological digestion process with co-digestion of different waste, and you get the biogas, which can be used for different applications, and you get the digestate, also has a lot of nutrient value, which can be used for as a manure. And the fibrous waste, that is banana peduncle, and the fibrous waste and the sewage sludge, especially the sewage sludge, dewater sludge, can be mixed together. It goes for the thermal drying in the solar accelerated process. After that, it goes for a thermal pyrolysis, and we get the energy out of that. Bioenergy can be used for any applications, and the biochar we get, and the final, and this also can be used for soil remediation. So this is the integrated approach how we try to handle the this municipal solid waste for urban areas. When it comes to the opportunities in environmental engineering, I'll not take much time, but I'll just cover to some extent. Here, actually, come to the environmental engineering aspects, we have different type of opportunities available for the environmental engineers who are coming from this master's degree, or not even sometimes now actually even a bachelor degree in environmental engineering is also offered in some universities. So the industry is a major opportunity. You find a lot of opportunity in industries. Process industry, I was mentioning about the different process industries generating the air emissions and the water pollution and other things. So wherever there is a process industry where we have a lot of air emissions or emissions of wastewater, so there actually they should have a pollution control equipment which has to be monitored and reported to the regulatory authorities. So that is one major area where actually the environment compliance has to be done, and the environmental treatment system has to be monitored. If you have an active sludge process, or if you have a incineration plant, or if you have a reverse osmosis plant, all those things has to be monitored and completely controlled with the help of environmental engineers. So environmental engineers and the environmental chemist plays a major role in the industries in the operation maintenance of the plant, and monitoring and reporting. And when you want to report, actually there are now new regulations on reporting on regular basis to the regulatory authorities. That monitoring also has to be reported. So where like have a lot of requirement of environmental people in the industries, and now actually new concept of eco label. That means green products are also coming up. Somebody is manufacturing a product which is recycled product, or we go for a green product. So all those things requires a lot of inputs from environmental engineering side. These are the opportunities available for industries. Any process industry, there will be a requirement. Apart from that, we have a lot of opportunities, major opportunities available in the area of design, consultant services, and implementation of treatment plants. So the process design of treatment plants is a major area where actually companies, big companies, where actually they who execute this implementation of individual effluent treatment plant or common effluent treatment plant or solid waste management facilities. They want process engineers or environment engineers for design of this treatment unit, and assessment studies. For example, if there is any new plant, or if you want to improve impact studies, the environmental impact assessment or something like that, if you want to do, we have a lot of requirement. And the water quality assessment studies, if you want to do a surface water, or if you want a groundwater, we have to take a lot of samples at different points, and we have to do a analysis. So there are also a lot of opportunities available. And actually the existing plants, for example, you have designed a plant, already the plant is operational, we want to have a upgradation of the existing system. There is a new norms coming from the pollution control board, they has to be upgraded the facility. There also the design and consultancy companies engage the service of environmental engineers, where actually they'll be involved in upgrading the facility. Retrofitting of the new technology, retrofitting of new equipments. For example, the conventional treatment system is there. If you want to go for a new energy efficient or latest technological changes, that also requires a lot of input from the design consultants, where environmental engineers plays a major role. And the optimization performance improvements. For example, the plant is already there, it is already meeting the regulation requirements, but the cost is high. So how to reduce the cost, or how to save the energy? In that case, we may have to do a lot of performance analysis and optimization of the system, by which we can look for opportunities and other things by which we can improve the performance, as well as also reduce the operational cost and also the energy demand. So that is also another areas where actually the design consultant will be involved, and where actually the environmental engineers plays a major role. So these are process industries, and the consultancy services for meeting the requirements of process industries. Other area is the research and development, like the research institutions, regulatory bodies. Regulatory bodies requires environmental engineers, MOF, Central Pollution Board, Central State Pollution Board, civic bodies who manages of waste, municipal waste, metro water, Tamil Nadu Water Supply Drainage Board. We have a lot of energy, water related and wastewater related, environmental related activities of the government, which requires monitor the environmental impact. So they require a lot of environmental engineers. And research and development institutes, research institutes like CSAR, we have our CLRI, NERI, and a lot of other research institutes requires a lot of environmental engineers to carry out the studies on the to develop new technologies for management of waste. Apart from that, we also have a lot of international institutes like United Nations Environment Program, World Bank, trade organizations, CAI, FICCI, all they have a lot of environmental activities, related activities, where actually they take the help of environmental engineers, environmental experts for the project evaluation or execution, implementation of the projects. This lot of opportunities are available. This may not be sometimes actually the long-term programs are also available. Sometimes short-term expertise, 6 months, 1 year expertise are also available for existing, assessing the existing facility or improving the environment for a particular regions, Asian region like that. We have Asian Development Bank. All these things also have a lot of opportunity for environmental engineers. Then EMS and other services where we have other compliances. For example, if somebody wants to do a environmental, EMS ISO 40,000, or if they want to do ISO 18,000, all these things they require environmental engineers, and they will be playing a major role in meeting the regulatory or voluntary compliances. Some people want to do a eco label, green label, or something like that. They are also required. And the environmental policy, as I mentioned, the MOF or the environment level, and also the NGOs, who plays a major role in the strategic assessment of the policies and also the implementation of policies on recycling or bring up new regulations. The policy related also requires a lot of environmental expertise. Apart from that, we also require a lot of teaching people, faculties, research institutions requires a lot of environmental engineers for the teaching in the field of environmental discipline and environmental education, awareness creation. So the NGOs and programs, they require a lot of expertise to create awareness, offer training programs for the operators, for consultants to give training programs. And as I mentioned, life cycle and other areas, sustainability, ecological, sustainable aspects. Also, we require a lot of environmental inputs. So here, all these areas, we have a lot of opportunities for the environmental engineers, including different disciplines are also involved. For example, if you want to do environmental impact assessment, only environmental engineers cannot be able to do it. They require expertise of other branches of science, biologists, maybe even chemists and water experts, groundwater experts. Like that, they require a lot of expertise, and also they require some expertise on the forest, ecosystem analysis. All those things are required. So there is a lot of opportunities available for environmental engineering in these major categories. With that, I'll just like to thank the our research team, our director CLRI Chennai, and our head and my colleagues from the Environment Division, and my research scholars and project assistants who contributed in this project. And will also acknowledge the funding agencies, DST Department of Science and Technology, Indo-German Science and Technology Centers, and our industrial partners, Ramke, Biomecon, Lehman. We can see this is an environmental team in our lab, and this is a project team of the second project, German partners and Ramke and the industrial partner. This is the team of the first project, German professor and other partners from industries. I'd like to thank CIT for giving me this opportunity for making this webinar possible for benefit of the lot of people. And if you have any questions, I'll be very happy to answer any questions. Thank you.
Sir, thank you very much, sir. Yeah. There are few questions from the participants.
Okay.
I will that is just read the questions.
Okay. Okay.
Please.
Sure, sir.
There is a question by Dr. B. Vasanti. Okay. What are the entrepreneurial opportunities in waste management?
Entrepreneurial opportunities, actually, we can think of having a lot of recycling. Recycling is another area where actually very less people are working on. A lot of things can be recycled. So that recycling opportunities can be explored. For example, the plastics, wherever the plastics is there, we have to have some sort of collection systems, dedicated system by which we can segregate that waste and try to find a recycling applications. We can connect the waste generator and the utilizer or recycler. And similarly, industries also we can find some industries generating small, for example, fly ash based waste. So we can think of having your own small manufacturing facility like brick manufacturing facility, or having utilizing the waste as a raw material. We can have some products, construction material products, try to reuse it. And even the construction waste now, actually new construction demolition waste is also a new area where actually the waste also can be collected, and it also can be treated such that it can be made as a recyclables. So wherever there is a waste, actually for this, it's a mismanagement. So what we have to do is we have to connect the entrepreneur is the one who connect whatever is a waste. That is, for some people it is a waste, they don't know how to utilize it. So for some people there is a demand for raw material, so we have to connect. So that is how entrepreneurs have to be very innovative in thinking that connecting these two people. Now I've seen a lot of new concepts are coming up, even recycling the plastic waste, making a lot of products out of it. Even any industrial waste, we can think of some utilization opportunities, and we convert into a useful product. And it is also safe, and we have to ensure that safety and the other aspects into consideration. So there are a lot of opportunities if we can think in that direction.
Sir,
Yeah, please, sir.
next question by Gaurav Kumar Biswal. I have done a project with municipal solid waste materials and burned them in a incinerator machine, which was hard to find nearby me, and also it cost is high. So, is there is any alternative method to burn the solid waste? As by burning all solid waste, I got bottom ash, which is cheap cost against natural coarse aggregate.
Yeah, this incineration is actually there are some companies which manufacture small incinerators. We can do lab scale incinerators, and we can do a lot of study on that. And we even, for example, some of the studies we have done in our case also, we have not gone for a small incinerator. We have taken the help of other incinerator facilities that is available for different facilities. For example, some of the biomedical facilities, small incinerators may be there. We can take their help, and maybe 1 or 2 days we can operate your waste and get the stand and monitor the parameters. So we also have done something like that. So like that, we can look for the small incinerators in industries or biomedical facilities may be available, where you can try your studies and monitor the parameters. And with respect to the waste, what is that, sir? Fly ash. What is the question related to fly ash? Ash, bottom ash. Sorry, sir, I didn't hear you, sir. I now hear you.
That can be used for bottom ash to make it as a natural coarse aggregate against.
Yes, yeah. That actually
Instead of
that
coarse aggregate, bottom ash can be used for,
yeah, that actually we
bottom
have
ash
to.
can be used for coarse aggregate.
Yeah,
Yes, sir.
that possibility is there. We have to check the quality, and we have to ensure that there is no any other contaminants like heavy metals, and it also meets the requirement. We can very well use it. That is possible. We use for coarse aggregate, or as a fine aggregate, or as the construction material, we can use it partly. Partly replace that. You cannot completely replace it. Partly can be used.
There is the next question by Dr. Ramesh. How will you remove the muta, mutagenic, mutagenic elements from the solid and liquid waste?
It's actually
Mutagenic.
mutagenic compounds. Actually, the mutagenic compounds, we have to first identify, as mentioned earlier, we have to identify the compound and what type of, I mentioned about the different treatment technologies, like new technologies on the, especially in the area of expertise using the biotechnology or advanced treatment methods, where actually we have to look for the chemicals, that is, which are the chemicals or what is the responsible compound. Then you have to take a model compound and you have to do study on the maybe a biotechnological approach of degrading that, or we can go for a chemical method of treating that mutagenic compounds. So we have to take what are the compounds, identify that, and go for this. Or we can also go for possibility of looking in the opportunity of filtration using modern technology, and also we can also explore the possibility of adsorption, also to some extent with the nanoparticles, things like that, and oxidation also we can explore that.
Question, Mr. Dinesh Kumar. Is there any license requirement to be an environmental engineering practitioner? Whether there is any license requirement to practice as an environmental engineer?
No, once you have done your master degree, you can do it. To my knowledge, there is no such environmental requirements. But some, for example, if you want to apply, depends on the requirements. Case to case, it varies. For example, if you want to practice in a government system, they require a qualification. That is required. For example, if you see the market, there is no need of any specific environmental engineers. I see a lot of people from other discipline doing field of environmental engineers. So there is no requirement. If you want to be an entrepreneur, commercial aspect, there is no need. But if you want to do some of the things, like for example, if you want to do environmental impact assessment, so then actually there is a empanelment of consultants done by the state pollution board. They'll give a list of requirements. They used to put a call, and whoever is eligible consultant has to apply. At the time of eligibility requirement, they'll ask for the specific requirements. That time actually you have to have a specific qualification and other things. You have to submit to the pollution board, and you have to get enlisted as a consultant for carrying out some of the studies. In that case, each state pollution board have different norms that has to be followed. Otherwise, if you want to do it on your own, there is no need of any specific things, but it is all based on the entrepreneurship quality and opportunities available.
Next question by Ratna Kumar Vedachalam. What might be the minimum budget for a digester with automated facility with pressure and temperature?
The minimum budget of it depends on the capacity. It depends on the what capacity. Yes, at minimum budget. But actually, if you go for if lab scale studies, if you want to go for lab scale studies, what we have lab scale equipment which we procured is a digester. It's a lab scale experiment setup. It costed about 16 lakhs, which continuously monitor the biogas and it will measure the biogas alone. But if you want to go for a little higher capacity with a simple pressure and other things, we have it can go up to 3 to 4 lakhs must be possible. It depends on the capacity, what capacity you're looking for, and material of construction, and what type of online monitoring systems you want to measure. There are a lot of suppliers in the market which can give you this.
What are the major process in food waste recycling?
Food waste is not a major problem because actually only thing is it's easily degradable. There is no much problem. Only thing is we have a simple filtration to ensure that filtration in the sense pre-sorting to ensure there is no plastic things like that, and we have to ensure that there is no other materials, what you call the foreign material in that. If there is no material, we can have a simple crusher, mixie type of things which will shred the waste and it directly pump into the digester. So there is no need of much pre-treatment in case of food waste. Very simple pre-treatment is sufficient.
Okay, sir. Thank you, sir. That's all the questions from the participants.
Okay, okay.
You want anything add, sir? Otherwise, can you wind up, sir?
Yeah, we can wind up. I thank CIT for providing this opportunity for sharing my views and experiences on the area of research opportunities for the environmental engineers. I hope it will be very useful for all of them, and each one will get benefit out of it. I hope everybody will work towards safe environment, and will give the same environment to our future generation also. So that is where actually I am also trying maximum to disseminate this concept of environmental to the extent possible for all the young peoples and the students. Thank you, sir. Thank you for giving me this opportunity. Thank you, sir.
Thank you, sir. I
Thank you.
formally propose vote of thanks.
Thank you. Thank you.
So your lecture and webinar was highly useful. I think you get a lot of feedback from the participants. The session was very much useful. It is more informative like that. Very good
Thank you, sir.
presentation. Like that, lot of things are coming in the chat box. So
Okay,
from
sir.
our side, you have covered in all the areas of environmental engineering, starting from the environmental waste management, water treatment, energy, various methods of including RO in the various technology adopted recently in Singapore and all also you have explained. Many other things such as waste from the our Coimbatore market, a case study, and also that chicken and food waste, that is meat, fish, etc. It is a fact you have explained 30% of waste is there from the chicken and meat, fish, etc. That is one of the fact for me. It is new. So this will be highly we have to concentrate and study on it. So really thankful to you, sir. We will take it to you some of the research in our areas, and maybe our institute further willing to take up study with your help and your organization. Thank you very
Sure,
much, sir.
sir.
I also thank all the participants for your active participation in this webinar. Thank you very much.
Thank you, sir. Thank you very much, sir. Thank you, everyone, for the patient listening. Thank you, sir.